by Bogdan Bocse from architect from Adviz and Mr. Alexandre Leroux, founder CEO at Adviz. He talks about the rise of digital audio, dueling between big data and fast data. Thank you.
Thank you very much. Is this thing working already? That's me? No. Is this thing working already? Yeah? Can you hear me? Fantastic. Okay. Well, thank you very much for coming. My name's Phil. This is Bogdan. And I'm sitting right in front of the... All right, let me move. Okay, cool. Hi. So, is that our presentation? Yeah, fantastic. So, I understand you guys are interested in big data in general. But before we talk big data, let's first talk about rock and roll and music, okay? Because after all, big data and all the geeky stuff that we do is just there because we want to solve a business problem, okay? And that's the stuff we're doing. Next slide. Who is controlling the next slide? Who's got a zipper for the slides? Ah, you stole it. They have it? Okay. Yeah, if you could just arrow down, that'd be lovely. You have the controller. Fantastic. Okay. So, let's talk about rock and roll. So, this is the business problem we're trying to solve. And big data is just like a tiny bit that helps us solve a big, huge business problem that is worth something like $150 billion. So let me tell you more about music. You see the little monkey there? This is like pretty much how my mom used to buy records, like 50 years ago. She still today has this huge collection of vinyls, you know, discs. She's very proud of them, the Beatles and things like that. It's not really convenient. It's huge, it's massive, it's taking a lot of space. It's actually crappy technology, okay? But it gives a lot of emotions, okay? This is the whole thing. This industry today, the record industry, is something like $100,000 billion every year. But things are evolved. People today don't buy records anymore. I suppose you don't buy records anymore, okay? Me in the 80s and the 90s, I was very proud of my collection of cassettes, of tapes, okay? Then I evolved, bought CDs, spent a lot of money on CDs. That was crazy, okay? Started using Napster. Today, I'm buying things on iTunes. And actually, the way I'm consuming music is today totally different. I don't buy anything. I don't want to own anything anymore. Okay, I've got everything in the cloud. I can listen to anything I want, whenever I want. I have my own music, and I'm also listening to radio stations. I can listen anything I want, all the stations on the planet. The big thing about FM is that you can only listen to Kiss FM if you're in Bucharest or WNYC if you're in New York. When you're using internet radio, you can listen to pretty much any single station that you want. And more than ever, music is part of our lives. I don't know if you guys are listening to online music. Who amongst you has ever listened to music on the internet or bought something on iTunes or is a Spotify user or a Deezer user? Just raise your hands if you've listened to music. This is pretty much everybody, but 2 people. All right? This today is the way that we consume music. All right? And that brings a huge business problem. Because, let me skip that one. Because a couple of years ago, because people were buying CDs, they were spending money on CDs for record labels, their business was pretty simple. The more CDs they were selling, the more money they were making. For radios, radio stations, the way they make money is that they don't pay for music that they air on FM or AM or whatever. What they do is that they sell advertising on their stations. That's the way they make money. They don't need to pay for the content they're using because record labels consider that radio stations are actually amazing marketing channels. This is the way for you to get to know new artists, new, music genres and things like that. But all that old industry, which is worth today $150 billion, so $100 billion of CD sales and $50 billion of radio advertising, all that is completely changing. And all those people that are in this business see their business completely change. Some of those companies are actually on the verge of disappearing. And we, We, when I say we, we're AdsWiz. We're a company that pretty much wants to power that revolution. We want to help build those new business models that enable people to listen to the music they want. They don't need to pay 15 euros for a full CD. They can listen to anything they want, wherever they want, any sort of device, okay? But that whole thing is completely changing the business. And, sorry, I'm not sure this thing is working. So, our company is called AdsWiz. And yeah, the first thing I wanted to clarify is that we're not actually an airline company, okay? We're a technology company. We are pretty much, it's a European story that started somewhere in Belgium. But today, we're pretty much like 100, 120 people. We've got 30 people in the Silicon Valley in San Mateo. And we've got here in Bucharest, most of our research and development, 60 people. The reason is a very long story. The co-founder and myself, we started the business here a couple of years ago. We fell completely in love with the ecosystem, the quality of the engineers. We started building great teams here, and we just couldn't possibly think of building a great company not from Bucharest. So, sorry. Where should I point this thing to? Does anybody know? Right. So what we do is what? We basically do, maybe you're familiar with a product called Google Analytics, okay? That pretty much helps you understand the traffic of websites and things like that. But we do pretty much the same, but for online radios, music platforms, digital stations, even FM stations that simulcast online, things like that. Next to that, we also have a platform called an ad server, which is a piece of software that enables publisher, people that own content, to manage advertising. But this thing is much more, let's say, sophisticated than traditional advertising. Today, when you listen to a radio station, you pretty much are exposed to a lot of crappy ads. Probably a lot of ads that are not relevant for you, okay? What we do is we've built a piece of technology that enables advertisers to really target people they're interested in, so that you get exposed to ads that are a bit less crappy, a bit more interesting to you, okay? In addition to that, we also built the equivalent of a stock exchange. I'll come back to that later on, okay? But basically, this thing is what? All the advertisers on this planet are connected through a system, and they can buy media inventory, or they can find audience on almost all the stations and the music platform on this planet. And this is pretty much the system that we've built. As you can understand, this system collects a lot of data, and this is where big data comes into play. So before we start talking about technology, I just wanted to give you some sort of background on the business side. Now, let me give you, this is a couple of stuff, and by the way, I see there is like a mistake. When our system runs like in full-blown mode, it's not 100 Amazon nodes that we're using, it's 1,000 Amazon nodes. So right now, it's pretty much a live system that whenever there is somebody that listens to an online station, or to Spotify, or to Kiss FM or there is a small message that comes to our system. We analyze who you are, and we're trying to expose you to the most relevant ads, okay? We do that on about 10,000 stations and music platform worldwide, okay? So if you look at like pretty much 2 stations out of 3 on this planet are connected to that system. So, yeah, these are some of our customers. So Hired Media, which is like, let's say the largest radio company in the US, it's 850 stations. You probably know iTunes from Apple. These are SoundCloud. Does anybody listen to SoundCloud? Remix, mashups, and things like that? Well, it's really, really, really cool service. Well, these are the kind of things that, the kind of people we work with. And all those guys are completely revolutionizing the way that music is sold, music is consumed. That is very, very exciting. Now, big data. Okay, now that you have some background, let's talk about big data. Let me give you a concrete use case of why is it that we care about big data. So imagine that in 3 years' time, you'll be driving your car. And at that time, most probably your car will have a media and entertainment system that is connected via 4G or whatever to the internet at all times. You'll have Wi-Fi inside your car and everything. Your radio will pretty much be an internet radio. Okay, you'll have a connection to your Spotify account, or your SoundCloud account, whatever. The thing is, you'll be connected. Now, when you'll be driving, not far from here, whatever, on Chaussea Chichelev, or you'll be exposed to an ad break at some point in time. And what we'll do is we'll be sending some data about you to a lot of possible buyers, people that are interested in engaging you and sending you a message, like L'Oreal or whatever, Apple or whoever, okay? And what we'll do is that we'll send messages to all those blokes and tell them, listen, there is somebody driving there at not far from Chichelev. This is roughly, you know, the profile of that person. Who is interested in exposing that person to an ad? And all those people will check in their systems if they have like some sort of campaigns they want to expose you to, okay? And they will bid. They will try to buy airtime, okay? They will try to buy a couple of seconds of your time. We'll get all those bids from all those people, select the winner, and expose you to that ad that is completely relevant to your case. As you can understand, that means collecting a shitload of data. When I say a shitload of data, it's petabytes of data every single hours. Yeah, our data is huge. So, of course, because we collect a lot of data, we're interested in user patterns and user profiles and things like that. But not only that, okay? What we also do is, as I was explaining, is to do real-time user profiling, okay? So we're using all that data to really try to understand who you are, okay, so that we can optimize the messages you're exposed to. Yeah, great. So, yeah, I mentioned advertising pretty much, and this is what Google has invented. It's pretty much become a different business than before. In the past, people used to buy, let's say, if you want to advertise on TV, for instance, this is still what happens, people buy like some figures. They buy a belief that if you advertise at 7 o'clock in the afternoon on TVR1, there'll be 10,000 people watching the stuff. Okay? It's pretty much theoretical. What Google has brought to the industry is something different. Said, listen, we have live data there. Okay? We can use all that live data. We know exactly how many people there are there. And also we know information about people. So we can really provide more information, more data to advertisers so that they can, on the fly, decide whether or not they want to advertise and to whom they want to advertise. Okay? So pretty much the whole media industry is now resembling more and more like the stock exchange. Okay? You have on the one hand music platforms, radio stations that represent supply, and you have advertisers and media agencies that represent demand. And all of that is connected through a market, okay, which works in pretty much real time. Right. So Bogdan will, let's say, delve into how exactly we're using big data to power all these things. Right? Is that the slide you wanted to start with?
Yeah, that's my cue. So, you know that joke about big data and thin sex, right? Everybody talks about it, it's cool, everybody knows they should be doing it, but nobody knows if they're doing it right. And one of the wrong things about big data is that it's just one word, but it expresses so many things. And I wanted to delve into the types, first of all, of data stores that they are available. First of all, you have the data stores everybody's been accustomed to, the ones that are consistent and highly available. Big data actually means exploring the other two types of data stores. The ones that are not always strictly consistent, I mean the ones that always give the same answer to the same question to the millisecond, and the ones which are not always partitionable. The ones which are not always available. This is the first distinction that needs to be made if you want to delve into big data, because what happens is that people think big data is one solution, but it's not just one solution. And for our case, we had very practical problems. As Phil said, we have a lot of data. That's the big part, right? We have roughly 1 terabyte of new data per day that we need to process and store the results of processing of, and so on. And MySQL and Oracle DB and conventional PostgreSQL just won't cut it. no matter how big the machines we use are. But the next question, when you want to start a big data project, or when you want to use big data into one of your projects, is to ask, okay, it's big, it's a lot of data, but how do I need to access it? Do I need to access it fast? Is it big and fast data? Do I need to make very complex queries on it? Or do I need to make structured queries in a predictable way? And depending on the answers to these questions, or at least to this question and to a few others, you choose the kind of solution you go for. And I'm gonna go into some of the on the types of solutions we have in our architecture. At the core of our architecture, this is the real-time thing. And by real-time, I mean we have 500 milliseconds to decide which ads I'm going to give to 1,000 users. That's real close to real-time. For those systems, we need millisecond response. We have data stores which have 1 to 4 milliseconds response time. That's the fast part. Of course, on those data stores, you cannot exactly run very complex reporting queries. The other layer is the layer that tunes and controls our delivery systems short term. Think with an hour, 2 hour horizon. Okay, bad spot. Those systems have response times around the minutes. And the last loop, the one in red, is the reporting, forecasting, and planning queue, which doesn't need to provide results or refresh data, I don't know, in 5 minutes. It's okay if it refreshes it every couple of hours or a couple of times a day. But this kind of systems run very complex queries. And now I'm going to go pragmatically into some use cases that we have. First of all, we have this big fast data use case or situation where when we receive a request for an ad, we need to decide, we need to look up what that user has seen, what that user has been exposed to, what exclusion principles apply, and we need to make that decision in 500 milliseconds, but for maybe hundreds of ads. That's why the response times that we require from our data stores are to the milliseconds. What happens is that if you use a big data solution that guarantees you persistence, that basically writes on disk or on SSD or whatever, there's no way you're gonna consistently drop below 10 milliseconds. You cannot consistently do that. So what we employed was the so-called cache aside pattern. Means that you have a data store which on average gives you 1-2 milliseconds response time. But every once in a while, when the data it accesses gets older and is no longer in this front layer, it goes to the persistent data store and it gets it from there. But this happens in only, I don't know, 10, maybe 15% of the cases at worst, which gives you an average response times which is satisfactory towards the business need. And the actual business need in this case is I cannot stop the stream to say, oh wait, the music has stopped for about 2 seconds because we're looking for ads. We cannot do that. And this is an example of big data where this is the big layer which can store, I don't know, terabytes of information if need be. We're up to hundreds of gigabytes now for this layer. And this is a fast layer which stores, let's say, in the tens of gigabytes of data. And both of these layers are scalable independently. It means I can have 4 machines on the first layer and 8 machines on the second one. In particular, for the fast layer, we use Redis Memcached, and for the second layer, we use DynamoDB, although there are, of course, other solutions that would have been compatible, like Cassandra or maybe even HBase. Okay, another use case. This is something very simple that in all likelihood you've heard about. You have this big pile of work. In our case, we have ads to encode to with different codecs and with different properties. That's one of our use cases. But we have a lot of these encoding jobs to do. And the rational, predictable, common sense thing to do is to split all this work between a lot of workers. And what we get is that we use simple queue service from Amazon to distribute this huge workload of millions of encoding around a cluster of encoding machines, which varies in size. What this does for the business is that maybe this guy comes in, says, well, it's taking too long to encode more ads. It takes 2 days to encode a new ad. It's unacceptable. This sort of architecture allows the technical side to say, well, give us more money and we'll fix it. And we turn a problem of, oh, we should research how we could encode faster into a problem of setting the size of this element here. Of course, you have more nodes, he pays more. But I sleep at night. So it's kind of a, he doesn't seem very happy, but he is. No, I know he is. Okay, now let's take this pattern and make it even more complicated. Let's say that the results are not just simple files like MP3 files that I play and that I need to encode. No, maybe the result are the structure of our traffic over 3 months, which I need to run drill down analytics on to find out how the traffic is going to be and how the campaigns are going to deliver. Now, I do the same thing. I split it into workloads, which I process over a variable number of machines. I put it in a data store, which in this particular case is Amazon S3. But then the business user comes again and say, yeah, you have all these great results, but I need to run queries on that results. I need a number. I need you to tell me how many ads I'm gonna sell in New York on Android device between 10 and 12 a.m. to men who listen to jazz. And I need that answer in 5 seconds, regardless of the targeting criteria, which I will not tell you before. So what we do is that we take a sample of our traffic, we process it through our simulation and prediction algorithms, we write the results here, and at the end, we copy all of this result data into a data warehouse, which in this particular case is Amazon Redshift. This data warehouse allows us to run queries on 150 gigabytes of data, and not queries of give me that record. Queries of compute a sum of this very large function over all the data where these conditions apply. And we get a response in 4 or 5 seconds. Now, additionally to this use case, you can run into situations where you need to make sure that all of these workers finish their work, and there's no work block or work item left unprocessed because of some reason, an error, a node failure, whatever. What you do then is that when each block is finished, it is marked as finished in this in this state store, which is highly available. And at the end, after all the work is done, the master node just checks, is there anything left unprocessed? If there isn't, great, we'll move on to the next step. If there is, we should requeue it and reprocess it. So these are some of the patterns we work on, or we work with, and these are some of the technologies we work with. Now, it's not, as my fourth speaker said, it's a new market. Technologies apply all the time, and the thing I like about my job is that we get to try out some of these technologies. I'll be honest, some of them don't work out. Some of them we throw away and we pick the other one. But it's a very interesting ride, and if you have questions about particular, I don't know, use cases or ways you should use big data, you know where to find us after the presentation.
All right. Thank you. Thank you. There might be questions now. There might be questions.
Questions?
That was so clear. No questions?
Please.
I'm going to move away from that.
So out of the 5 billion hits per day, what would be a peak per second, let's say?
What would be, sorry?
A peak traffic per second, let's say in a...
Let me do a, I think around 10,000 requests per second in peak. The absolute peak we have seen. But the thing we have to guard for is that I give you this answer today, and if we meet again in 2 or 3 months, I might say 20,000, because these guys keep selling.
I should ask you, many times, writing of a query task can be easier than cancel this query, because the replication and cluster of MapReduce translation of Hive can be take a lot of time, and in this type of business, the cancellation of query can be.
So the cancellation of a query.
I ask for a song.
Right.
I give up.
Okay.
And I start the query to the database.
Right.
And I want to cancel in this moment and wait immediately to cancel.
Okay. I think I understand the question. So this kind of query, give me an ad, select an ad for this particular user, doesn't go in Hadoop, because if it would go in Hadoop, it most definitely wouldn't get an answer in 500 milliseconds. For this sort, in 500 milliseconds, no way. For this sort of scenarios, we go to the fast layer, the one with the milliseconds, for which we use memcached and DynamoDB for the milliseconds time. The stuff that we use Hadoop and Redshift for are the reporting workloads, which go like, show me how many queries I had with this parameter in the last 2 weeks. And that has to go through gigabytes of data, and it takes some seconds. If you cancel that, there is a protocol in Redshift at least that signals the cancellation to the slave nodes as well. But until that query is cancelled, some resource will be wasted, of course.
Thank you very much.
Hope that answers the question. Any more questions, maybe?
Yes, so on the DynamoDB, if I don't confuse it to something else, when you make a query, you can have multiple results because it's a non-consistent, not strongly consistent environment. And what is the conflict resolving strategy you have with the data last right wins of what kind of?
We are fortunate enough in advertising that this sort of strategy with the last right is good enough. Is good enough for our use case. However, there are situations, and we have come across this situation, where you need strict consistency. And for instance, some of the data stores, Dynamo in this case, offers strict consistency, but at a performance penalty. We don't particularly need it, but if you were to work in banking or in some transactional system, you have the option, both in Cassandra and in DynamoDB, to make the writes strictly consistent with some performance degradation.
Questions?
More, please.
Thank you. My question is strongly related to multi-clusters. Are your applications running on clusters on different coasts in US or things like that?
Of different?
Different coasts, different data
Regional
centers.
areas, you mean?
Right.
Yeah.
Right, so geo-replicated, distributed eventually, and if you have this kind of
we have considered it. For the moment, most of our, our production workloads are in Europe. We have considered replication, and for this scenario, what we would have done is create 2 different clusters for all the big data part, and just replicate the relational data, the one in MySQL. Our replication model was more around the fact that if this client has most of the traffic from the US, then we'll set up his cluster in the US. Because otherwise, if you serve, let's say, a workload from both coasts or from several data centers, you'll incur huge charges for transfer. And that's a problem in the business case, not just technical.
There is too much data to do that.
So
much data to do that, to replicate in the streams.
The moral of the story is that if you go for the S3 strategy, then you will have to duplicate a lot of workloads. For instance, we have the primary data we have in S3, and let's say we keep that in the US, in S3. But then we'll have to replicate the reporting, the forecast, the encoding workloads on both sides. Either that or we have traffic for replication. We haven't come across that. We haven't split it on both coasts yet, so.
But it's anyway, it's 2 data centers. Actually, it's 3 regions in Europe, right? So it's already replicated, but we don't manage it.
It's not geographically replicated. That's the thing.
What is your opinion about recommendation system over your big data?
A recommendation system?
Recommendation system, because you correlate a lot of information, and it's very interesting for people to recommend some advertising products.
The nature of the business rules didn't push us in the direction of Mahout and let's say data mining strategies, because the algorithms we run on our data, the filtering, the prediction, the reporting, have pretty straightforward rules, and we are not necessarily, at least at the moment with the workloads we have, we're not necessarily looking for patterns. We know the patterns we need to apply, the business rules we need to apply. It's just that we need to apply them at a very large scale. So it's not, we haven't come across data mining, at least yet.
Thank you very much.
All right. One last question.
One more.
So I know Google is one competitor, and what is your strategy with the competitors, and how is it that you made the first place, or that what you said at least?
Yeah,
I think that goes to you.
No, it's a good question. So when you're in the online business or online advertising business, the first question that you get is, all right, guys, so Google will compete one day with you guys. So first, what we're trying to do is we try to focus on some niche market. We're trying to do it extremely well, and we do it before them. Of course, they could probably do what we do even better, because they have like unlimited financial means to do that. We're just like a couple of months ahead of them, okay? And that has enabled us also to create a market. So we have, like today, if you look at the market, a big share of the market is using our technology, and that's how we can protect our market share. If one day Google wants to fully compete with us, well, either they'll need to buy us or they'll need to quit the market. That's our hope, all right? But I don't want to be arrogant and obnoxious. Google, they're fantastic. It's an amazing company, so we shouldn't underestimate them. But by taking this niche approach and trying to do things like a year before they can do it, we sort of protect our market shares. That's the trick. And there is a chicken and egg problem. The more customers you have, the bigger the market you create, the bigger the barriers to entry you create. That's a little bit the reasoning here. But a lot of companies have tried to do that in the video business, for instance, and they have failed, either because they were a bit too slow or because they were not niche enough. And Google has trashed them. That's the stuff.
Okay, thank you very much.
Thank
Excellent,
you.
gentlemen.
All right.